Okay, let's dive into this. Welcome to The Explainer. Today, we're unpacking what is easily one of the most famous and honestly most persistent thought experiments out there. I mean, we've all seen the maps, right? The diagrams, those wild internet debates. But today, we're going to look strictly at the physics outlined in our source material. We're going to figure out exactly what would happen to our planet and, well, to us, if the Earth actually was a flat disk. This explainer is going to take you through the literal, physical mechanics of a flattened world, and I promise you, the reality of this hypothetical scenario, it's so much weirder and way more intense than you might think. So, would we fall off the edge? It's the most classic question, right? Like, if you just keep walking, do you eventually just tumble off into the absolute void of space? Or maybe, as the Earth moves, do we all just spin violently into the edge, like we're in some giant centrifuge? Well, the truth is, a flat Earth completely rewrites the laws of physics as we experience them every single day. Falling off the edge is actually the absolute least of our worries. To understand why, we've got to completely rethink how the universe actually holds us down. Section 1. The shape of gravity. Get ready for a massive rule change. The entire foundation of this whole thought experiment hinges on exactly how gravity behaves. Gravity is kind of the invisible glue of our reality, right? And changing the shape of the massive object we live on totally changes how that glue behaves. Just contrast our actual reality with this hypothetical flat Earth. On a spherical Earth, gravity is super predictable. It's uniform. Because all the mass is pulled toward a central point, gravity pulls in the exact same direction straight down, from literally all points on the surface. But for a disk-shaped Earth, yeah, that uniformity goes completely out the window. On a disk, gravity depends entirely on where you are standing relative to the center of the mass. So let's break down exactly what that means for your everyday life. If you happen to live right dead in the center of this flat Earth, you're the lucky one. Right in the middle, the mass of the disk is distributed evenly all around you. And because of that, gravity pulls you perfectly straight down, just like it does right now. You could stand there, drink your morning cup of coffee, and honestly, everything would feel completely normal. But the moment you start to travel away from that center point, oh boy, things get very strange very quickly. And this brilliantly illustrates the real problem with living on a disk. As you walk outward, heading toward the edges, the bulk of the Earth's mass is now behind you, back toward the center. So gravity doesn't just pull you straight down anymore. It begins pulling you down and sideways. And the further out you go, the more extreme that sideways pull becomes. You'd be constantly getting dragged back toward the middle of the map.
Which brings us to Section 2, a wildly warped world. Let's look at some truly bizarre surface effects.
Because, it's not just humans who have to deal with this sideways gravity, it's the entire environment. This massive gravitational shift would mutate the landscape of the planet into something totally unrecognizable. Think about water. Fluids naturally pool at the lowest gravitational point. So on our flat Earth, all the ocean water on the planet would be aggressively pulled toward the center, creating this one massive, bulging central ocean. And what about plant life? Trees naturally grow opposite to the pull of gravity. So as you move away from that center ocean, the trees wouldn't stand up straight. They would actually grow diagonally, leaning drastically outward just to fight against that relentless sideways pull. The landscape itself would look completely, absolutely surreal. So back to our original question, would you fall off the edge? Well, just picture the physical struggle of even trying to get there. Step 1, you start walking toward the outer edges. Step 2, that sideways gravity sharply increases the further you go. And by the time you get anywhere near the perimeter, step 3 kicks in. Walking on perfectly flat ground would literally feel like climbing a never-ending, impossibly steep mountain. The gravity pulling you backward would be so intense it would be nearly impossible to actually reach the outer edges of the Earth. So no, you wouldn't fall off. You honestly wouldn't even be able to drag yourself to the edge in the first place. Section 3. The cosmic space pan. We're talking deep underground danger now. The real danger of a flat Earth isn't just the weird surface gravity. It's what happens deep underground. Or actually, scratch that. It's what doesn't happen. A flattened Earth simply does not have the geometry to support deep, churning internal layers. And this kicks off a completely fatal chain reaction for everything living on the surface. Let's go through it. Step 1, we lose those deep internal layers. Step 2, because we have no layers, we have no movement of a molten liquid core. Step 3, it's the movement of that molten core that generates our planet's magnetic field. So without it, our magnetic field vanishes entirely. So the crucial point is Step 4. Without that magnetic shield, our atmosphere is just totally stripped away and we're left getting absolutely cooked by cosmic radiation. The entire planet becomes completely uninhabitable. And the cosmic weirdness doesn't stop with lethal radiation either. Think about how a flat disk interacts with the sun out in space. Depending on our orientation, the mechanics of a normal 24-hour day are completely broken. If the flat side of the disk is facing the sun, the entire planet experiences endless, blistering daylight. But if it tilts away or is positioned edge onto the sun, the planet is plunged into endless, freezing night. There's no sunset, no sunrise, just permanent, absolute extremes. Even just looking up at the sky would be a deeply unsettling experience. Take celestial events, for example. Right now, we're used to seeing the beautiful, curved shadow of a spherical Earth passing over the moon during a lunar eclipse. But on a flat Earth, lunar eclipses would look completely bizarre and, frankly, just wrong. You might just see a harsh, flat line cutting straight across the moon's surface, like a barcode. The entire geometry of the heavens would be completely broken. Which brings us to this highly evocative quote right from our source material. I love how succinctly this captures the absolute horror of this whole thought experiment. Quote, "So if Earth was flat, we'd be cooking on a space pan with no escape." I mean, think about it. We'd be pinned down by sideways gravity, blasted by cosmic radiation, and either frozen in darkness or scorched in endless daylight. A space pan is truly the most accurate and, yeah, slightly terrifying way to describe the whole shebang. Honestly, exploring this wildly warped scenario really highlights just how perfectly tuned our actual spherical Earth is to keep us alive. The turning core, the magnetic field, the uniform gravity, it all works together flawlessly, which leaves us with a truly fascinating question to end on. Since we rely so heavily on that molten core and those internal layers for our very survival, how do scientists actually know what's really inside the Earth? I mean, we can't dig down there, so how do we know it's not flat on the inside? That is a brilliant question and exactly the kind of real planetary science you should go explore next. Thank you so much for joining me on this explainer, and keep questioning the world around you.